Last module we discussed circuit and packet switching, the various network topologies like the ring, bus, star, and mesh, address types like unicast, broadcast, multicast, and the composition of a frame, how it has a header and a payload. This module continues the discussion of LANs by focusing on wired LAN technologies and explains how concepts from the previous modules form the basis of the Ethernet. We also discuss wired LAN technology that continues to dominate all other LAN technologies. Although the hardware devices, cabling, and the media used with Ethernet have changed dramatically, the fundamentals have seen little change. One of the most interesting aspects of Ethernet evolution concerns the way newer versions of Ethernet remain backward compatible. A new version can sense an older form and automatically adapt to accommodate the older technology. Ethernet was developed in the 1970s, was commercially deployed in 1980, and became an 802.3 standard in 1983. Ethernet is the most widely used installed LAN technology. Ethernet is a network interface protocol, a link layer, Layer 2 in the TCP/IP stack. This protocol describes how network devices can format data for transmission to other devices on the same network segment, and how to send out data out on the network connection. Ethernet affects both Layer 1 and 2, but is considered a Layer 2 protocol. Ethernet is a local area technology connecting devices in close proximity. Networks traditionally operating within a single building. Historically, Ethernet devices could only have a few hundred meters of cable between them, making it impractical to connect geographically in geographically dispersed locations. However, modern advancements have increased these distances considerably, allowing Ethernet networks to span tens of kilometers. Ethernet follows a simple set of rules that govern its basic operation. To better understand these rules, it is important to understand terms used in describing Ethernet. They are media, segment, node, and frame. The frame. These are the nodes that communicate in short messages called frames, which are variably sized chunks of information. This figure shows a composition of a segment. Point out a transmission, media, and node. Can you find one? There we go. Transmission media right here. And this will be considered a node. Medium. Transmission media in the diagram right here. Ethernet devices attach to a common medium that provides a path along which the electronic signals will travel. Historically, this medium has been coaxial copper cable, but today it is more commonly a twisted pair or fiber optic cabling. Segment refers to a single shared medium as an Ethernet segment. Node. These are devices that attach to that segment and are stations or nodes. The frame is not shown here in the figure. The nodes communicate in short messages called frames, which are variably sized chunks of information. This network diagram was created in Packet Tracer, a network simulation software we will start using in the next module. Frames are analogous to sentences in human language. In English, there are rules for constructing sentences, and each sentence must contain a subject and a predicate. The Ethernet protocol specifies a set of rules for constructing frames. For example, there are explicit minimum and maximum lengths for frames, and a set of required pieces of information that must appear in the frame. For example, each frame must include both a destination address and a source address, which identify the recipient and the sender of the message. The MAC address uniquely identifies the node, just as a social security number identifies a particular person. No two Ethernet devices should ever have the same address. The term frame format refers to a way the packet is organized. It includes details such as the size and meaning of individual fields. The main reason that older versions of Ethernet have remained compatible with newer versions arises from the frame format. The Ethernet frame format has remained constant since the DIX standard was created all the way back in the 1970s. Digital Equipment Corporation, Intel, Xerox. DIX. Commercially deployed in 1980 and standardized in the 802.3 standard in 1983. The Digital Equipment Corporation was a major American company in computer industry in the 1950s to the 1990s. It was acquired in June of 1998 by Compaq and merged with HP in 2002. The first 7 bytes of the preamble are all the same, 10101010. The last byte, or the start of the frame byte, is slightly different, 10101011. The 8 bytes of the preamble and the start of frame create a pattern of 64 bits. They are not officially counted as part of the Ethernet frame. The frame begins immediately after the start of frame without a gap. The figure illustrates the basic format and the details of the frame header. As the figure shows, an Ethernet frame consists of a fixed length header and a variable length payload, and a fixed length CRC, cyclic redundancy check, is a form of error checking, CRC. The 48-bit or 6-byte MAC address is entry for the destination and source addresses. The remaining field in the frame is the type field. The type field in an Ethernet frame provides demultiplexing and allows a given computer to have multiple protocols operating simultaneously. The protocols used on the Internet send IP datagrams and address resolution protocol messages over the Ethernet. This matches an IP address to a MAC address. Each protocol is assigned a unique Ethernet type, hexadecimal 0800 for IP datagrams, and hexadecimal 0806 for ARP messages. When transmitting a datagram in an Ethernet frame, the sender assigns a type, 0800 ether type. When a frame arrives at its destination, the receiver examines the type field and uses the value to determine which software module should process the frame. This figure illustrates the demultiplexing. Ethernet frames are said to be self-identifying because of the ether type field. Self-identifying frames make it possible to intermix multiple protocols of the same physical network and allow a single computer to use multiple protocols together. In computer architecture, the network interface card appears to be an input-output device, and it is connected in the same manner as a disk or video device. A NIC has 4 jobs. It handles address recognition of the MAC addresses, CRC computation, frame recognition, that's the ether type, and sending, receiving of frames. A NIC consists of a circuit board with a plug on one side. Most computers come with a NIC already installed. However, the NIC is independent from the rest of the computer, and a user can choose to replace the NIC without making other changes. Note: description: IEEE handles layers 1 and 2. A standard PC network adapter is a plastic circuit board about the size of a playing card. It has several computer chips to process signals from the network and the PC. The card slides into the PC's chassis and mates firmly with a connector on the motherboard. A steel bracket holds the card in place. The bracket may have a network cable jack or an antenna, depending on the type of network to which the computer connects. The bracket also has light-emitting diodes that indicate network status and activity. A network card functions as a middleman between your computer and the data network. For example, when you log into a website, the PC passes the site information to the network card, which converts the address into electrical impulses. Network cables carry these impulses to a web server somewhere on the internet, which responds by sending a web page back to you, once again in the form of electronic signals. The card receives these signals and turns them into data that your PC displays. In addition to the network card's hardware, it needs programming to make it work. When you install the card, Microsoft Windows loads software drivers for your card's make and model. Your browser, email, and other programs communicate through Windows to reach the network. Windows, in turn, passes data to the drivers that are programmed specifically for your network interface card. The card cannot function without the right driver software. Most contemporary network cards work with Wi-Fi wireless networks. These cards have antennae to send data signals via radio waves. Some networks still use wired Ethernet connections. These cables have a rectangular plug, which mates with a jack on the network card's bracket. In many new computers, network adapter cards are actually custom computer chips built into the PC's motherboard. Because of the nearly universal use of the internet, almost all computers include a network capability. Having the chips on the motherboard frees up a card slot for other devices you may want to add later. Computer retailers sell network accessory cards if you want to install one in a PC. For desktop computers, these are standard PCI cards. Notebook computers use smaller PC accessory cards that slide into a slot on the computer's side. A wired computer network uses cables called Ethernet or RJ45 to move data between client computers, switches, routers, and servers. A NIC provides a computer with the required interface for an Ethernet cable and also provides the translation necessary to convert data into a form that can be transmitted over the cable. Most desktop and notebook computers have motherboards with built-in Ethernet ports and do not require add-on cards to connect to Ethernet-based networks. However, some thin notebook computers lack Ethernet ports. Instead, these notebooks have built-in adapters for connecting to wireless networks. Ethernet has undergone several major changes, with the most significant changes in media and wiring. The original Ethernet wiring scheme was informally called thick wire Ethernet or ThickNet because medium consisted of heavy coaxial cable. This wire is formally called 10^5, 10 megabits per second at 450 meters. Hardware used with ThickNet was divided into two major parts. A NIC handled the digital aspects of the communication, and a separate electronic device called a transceiver connected to the Ethernet cable. The transceiver handles carrier detection, conversion of bits into appropriate voltages for transmission, and the conversion of incoming signals to bits. The most widely used network connection for personal computers is Ethernet connection. Ethernet is really a standard for computer network technologies that describes both hardware and communication protocols. Ethernet was commercially introduced in 1980 and has largely replaced other wired network technologies. Since Ethernet is so widely used, most modern computers have a NIC built into the motherboard. A separate network interface card is not required unless some other type of network is used. Here you can see an Ethernet connection built into a motherboard. Several other connections are located directly adjacent to the Ethernet connection.